and welcome to the mathleague YouTube channel. The following video was recorded by one of our staff members.
Hello, I'm having a big party for my algorithms loving friend in a few hours. I need to order some last-second food.
Simplex Subs is happy to help. For each sandwich, you must choose one type of meat, one type of vegetable, and one type of bread. Exactly 1 unit of each ingredient is used to make a sandwich. Today, we have 10 units of each of ham and turkey, 15 units each of lettuce and tomato, 5 units of sourdough bread, and 20 units of whole wheat bread, and that is it. What would you like to order?
I want to buy as many sandwiches as possible, but I'm very picky with what I order. Turkey can only be combined with tomato, lettuce can only be combined with sourdough bread, and tomato can only be combined with whole wheat bread. Yes, I am very picky with what I order today.
Yeah, okay, let's see what we can do for you. All right, so you said that turkey can only be combined with tomato, and tomato can only be combined with whole wheat bread. All right, so that kind of determines what our turkey sandwiches can be. That's only 10 turkey sandwiches, then with using 10 of the tomatoes, and then 10 of the whole wheat bread supply. And that looks like your first item.
Okay, 10 turkey sandwiches already.
Cool. All right, so what's left is the ham sandwiches. And you said that ham can go with what? Remind me?
Okay, ham meat can actually, I didn't really say what ham can go with, so it can go with anything as long as the other conditions are met.
Oh, sweet. Okay, that's good. So for the ham, then we can get some of the ham to use up the rest of the tomato.
Okay, that could work.
Cool. And that is 5 sandwiches because we only have 5 tomato left. All right, let me write that down.
Okay, I'll take all those 5 sandwiches with ham, tomato, and whole wheat bread.
Okay, cool. So, and you said that ham can go with basically everything, but lettuce, what's the restriction there?
Let's see. Lettuce, it can only be combined with sourdough bread, as I said earlier.
Okay, got it. Thank you. Yeah, it's a lot to remember because you are indeed very, very picky. So we've got 5 pieces of ham left, and we can use that within the lettuce.
Okay.
And sourdough, because lettuce only goes with sourdough.
Got it.
All right, and that's 5 sandwiches of those.
And yep, I'll take all those 5 sandwiches with ham, lettuce, and sourdough bread as well.
All right, cool. And each sandwich is $7 each. So can we get any more sandwiches? Oh shoot, that uses up all of our meat. So I guess that's it.
Okay, I'll take it. I'll take all those 20
right.
sandwiches.
Yep. So let me just make sure that I confirm your order for you. Let me be sure that I show you the guest check. Okay, so here's what I've got. First I have our turkey with tomato and whole wheat bread, as you said, and we wanted to get 10 of those. That used up all of our turkey. Next we got our ham with tomato and whole wheat bread because tomatoes and a whole wheat bread go together, and that's it. So 5 of those because ham you don't seem to be very picky about. That's $35. And then finally we want to use the rest of the ham and then lettuce and sourdough. And that's 5 of those, $35. So your total is $140. Sounds good?
Sounds good. 20 sandwiches in total.
All right. Thank you very much. Just got the money. And yeah, you're right. It turns out that we did luck out here, as all the meat that we had ended up being compatible with very, very particular constraints. But that didn't have to be the case.
That reminds me of that background decoration behind me.
Yeah, so here's a graph. We can think of this as a bit of a graph problem. So how do we construct this graph? Well, here's our source, which is you, and you wanted to buy the sandwiches, and then there's the sink node. And basically we have outgoing edges from the source to the sink. The sink is where we find our total of sandwiches. So how do we partition this graph and make it work? The capacities work to our favor. So we can think of it as some sandwiches flowing out of the source and then into the sink. And we have our meat because we must have exactly one type of meat. Then we have our veggies, because we must have exactly one type of veggie. And then we have our bread, and we must have exactly one type of bread. And when you go through this whole thing, a sandwich would come out at the end. So like if we have one sandwich, when we have our ham, it goes here. That's one, and then our veggie, and then our bread, and then here to the sink. All right, cool. So you might be thinking, what are these in nodes and out nodes? Well, how would we determine that there is exactly 10 units of ham or 10 units of turkey, and so on and so forth? We can't just have one vertex for the ham or the turkey because we need the next edges to go to the veggies. And how do we know how we're going to split them up? We don't yet. And what about these infinite capacity edges? Well, we don't really have to figure out a way to get from the meat to the veggies. That we can add as many as we want there. So we just model that as infinite capacity. I guess the other question that you might have is, why are there only some edges of infinite capacity? Why isn't there one here, for instance? Well, remember that you were very picky. If I had an edge of infinite capacity here, then we could then have lettuce with whole wheat bread. Do you want that?
No.
Yeah, so we need to make sure that those edges are not there, so we don't end up getting any sandwiches that don't satisfy your constraints.
Okay.
Yeah, so that's basically how we would construct this graph. And since you want to make as many sandwiches as possible, we want to figure out the maximum flow that can go through this graph. So we have our capacity constraints here, and we want to see how many sandwiches can go through, and each unit of flow is basically one sandwich. As it turned out, our maximum flow was 20 because we had 20 units of meat, and it all happened to add up perfectly. Our 10 turkey sandwiches here, and then 5 ham going this way, and then the other 5 ham going that way.
Oh, nice.
Now, let's say, what if we happen to have more unit of ham? 11 instead of 10. Well, we should be able to make one more sandwich, right?
Okay.
So, well, we could only make 5 of the ham, lettuce, sourdough sandwiches because there's only 5 of sourdough. Then the rest of the sandwiches had to be with ham, tomatoes, and whole wheat. But we used up 10 of the tomatoes when we made our turkey sandwiches, and we only had 5 left. And then that's 5 plus 5 is 10 ham sandwiches. If we had one more unit of ham, it wouldn't have done anything for us. So we really used our meats to the fullest.
Yeah.
Now, yeah, we were lucky here. And so how would we calculate these sort of max flows? This diagram here was nice, and we could just eyeball it pretty easily. Well, there's a pretty nice theorem called the Maxilloman Cut Theorem that says that the max flow is equal to the min cut. And I guess we're wondering here, what is a min cut? Well, it's a partition. And that partition is putting the source and some vertices in one part and the sink and the others in the other part. Turns out that this partition that I just highlighted was our min cut because we have our source capacity of 10, of 10 for our meats.
Ah, no wonder the slogan is max flow min cut.
Yep. And I bet you're going to have a great time talking about this with your algorithms loving friends.
Yep. Speaking of which, the food is getting cold, and I don't think I have more time to listen to your max flow min cut stuff. So I'm going to go get the food, and see ya.
Yeah, see you. Have a great day. Have fun at your party.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.